So in this video, I'm going to give you a little bit of background for what we're doing, excuse me, in 7.5. So remember what we're trying to do here is find the area of an irregular shape. But before we do that, let's start with a regular shape. Let me start with a rectangle. Okay. I'm going to take this rectangle and I'm going to put him right here in the coordinate plane. And let's pretend that this is a 2 and that this is a 4. So we know with a regular shape, they have a formula. So area is length times width. So 4 times 2 is 8. So if we were to divide this equally and pretend like those are all equal, but look, they're 8 squares. So 8 squares is our area. Okay. So let me take that same rectangle and let's put it in the coordinate plane, and I'm going to put it between two vertical lines. Let's say that's at x equals 2 and x equals 6. And let's put the horizontals at 1 and 3. So it's the exact same rectangle, right? We're looking for the area inside of here. And you can see that that gives this side of 4 and this side of 2. Now, we're going to do this with an integral, even though, of course, if you have a regular shape, you'd use a formula. But in an integral, what you want to do is you want to find a formula for the function on top. So this is y equals 3. That's a horizontal line function, or f of x equals 3. And this is a horizontal line function. That's y equals 1, or f of x equals 1. And what you want to do is you want to find the integral from the initial value 2 to 6 of the upper function minus the lower function. So upper minus the lower. Now in our case, our upper, f of x, is 3 minus our lower, which is 1, dx. Now, it is true that these are constant functions. So look, we just have constants, 3 minus 1. You'll have other formulas for those functions, though. They won't be horizontal lines. So this is from 2 to 6, 2 dx. And that means 2x evaluated first at 6 and then at 2. So 2 times 6 minus 2 times 2 is 12 minus 4, which gives us an area of 8, exactly what we knew it would be. And again, of course you won't do this when you have a regular shape. But we don't have regular shapes, and that's what the calculus is good for. So let's say this time I have, and I'm just going to make up two functions. Let's say that this is f of x, and this is g of x. And I want to know the area between here and here. And that's called the area bound by the curve. So this is the little area I want in here. So this is going to be, first of all, we need to know what this is. We'll call that x1 and that x2. So this area in there would be the integral. And remember, the lower, smaller number goes on bottom. The upper or the larger number goes on top. And look, f of x is always on the top. So f of x minus g of x dx. Now, sometimes you might have to do it in two pieces. So let's say I have this. Let's do the similar kind of thing. Let's do a parabola and a line. Okay. And let's say we want to go from x equals 0. And on this side, let's just put in another vertical line right here. And let's say that's at x equals 10. So, I want to know, so it would look like this. X equals 0, from x equals 0 to x equals 10. This will be, we'll call this one f of x, the line, g of x, the parabola. I'm not going to give you specific functions right now. It doesn't really matter. So g of x is our parabola, and f of x is our line. Now, I'm only going to go up to 10. So the area I'm trying to find is from 0, so it's all this area in between these, just right here. Okay? Now, we will have to find this point right here, because, look, it's switching. So to the left of this point, the parabola is on top. So g of x is the top function. And f of x is the bottom function. In here, f of x, just in here, f of x is on top. And g of x, right, and we're talking about just this little yellow part in here, is on the bottom. So we have to do it in two parts. Now, to find this point right here, this x value that we don't know, I'll call it x1. We know 0 to 10. We know that part, but we don't know that. So we have to set f of x equal to g of x to find x1. Now, you'll also find this point, but look, this will be out of range. So this will come up with something like x equals 15 and x equals 5. Okay, so there'll be, you'll get two answers because, look, they intersect twice, but you'll only use the one that's there. All right, so to do our integral here, we'll set them up here on the top. Area 1. That's going to be the integral from 0 to that x1 point, whatever it is that we found there, of g of x minus f of x dx. Plus, area 2 is going to go from x1 to x is 10. So from x1 to 10, and it's going to be top function f of x minus g of x dx. So when you're trying to find, what we're trying to find is the height of each one of these little bitty rectangles, and we'll add them all together. That's what the integral does. But that height is going to be the top minus the bottom. So say this was at, let's say this is at 10, and this is at negative 2. Well, that height is 12. 10 minus negative 2. 10 plus 2 is 12. You have to do the top one minus the bottom one to find each of those lengths. All right, now, in the book, or in the book methods, if you look at the examples, for example, and you have this function, but you don't have the graph, okay? So let me copy this. So you don't have the graph. Now, I'm going to give you the graph on the ones that you'll have to do. I'll give you graphs. And I'll have it shaded in. You will have to find that point right there, okay? And you'll have to know, what a vertical line is and a horizontal line and so forth. You'll see in the examples. But what they tell you to do is pick anything pick an x between negative 2 and x1, okay? So, for example, we said x1 is 5, so we would pick x equals 3. And you do f of 3 and g of 3, and whichever one is the greatest would be the function that's on the top. Okay, you know they intersect there. Okay, even if you didn't know what the shape looked like, you would just evaluate each function, and whichever one is the biggest would be the function that you would put on top. So that's what you're going to see. But I'm going to give you the graph and all the ones that you'll have to do on the test and on the final exam. But you'll have to kind of recognize the parts of the graph. So you'll see that as we go through some of the examples. So the main thing to remember is it's going to be the integral. And this is going to be your left x value. And this is going to be your right x value. Okay. And then you're going to have top function minus bottom function dx. And if the graphs switch places, where one is on top part of the time and the other part of the time, you'll have to find that point where that switch occurs by setting the functions equal to each other. And then you'll have to do it in two parts. So if they switch places, if the top and bottom functions switch places, and conceivably they could do it more than once, but you're not going to see one of those. You'll have to do each area separately. Okay, so let me do one more where we just set it up, and then you can look at the examples that I have provided. So let's say we have this. Let's say you have a cubic function, okay, and you've got a vertical line over here, like this, okay, and you've got a vertical line on the right-hand side. So they're going to give you those. So let's say this is x equals -6, and this is x equals 2. And so they'll say the area bound by x equals -6, x equals 2, f of x equals, and they'll give you the cubic function. Might be something like x cubed plus 4, okay? And they say the x-axis, or they may say y equals 0. Okay, so this is your bottom function sometimes, y equals 0, and then the curve is your bottom function sometimes. So this is the area they're looking for. Area in here, and the area in here. Okay, and it doesn't necessarily have to be the x-axis. It could be any horizontal line. But we got to do this in two pieces. We got to find this value x1 right here. And we got to do area 1 and area 2. So it's going to be the integral from -6 to x1. And look, y equals 0 is on the top. So 0 minus whatever f of x is, dx. Plus, picking back up at x1, going all the way to x is 2. And in this case, it's going to be f of x. Because look, f is on top right here. This function on top, minus 0. So this will be from -6 to f1, negative f of x dx, plus from x1 to 2, f of x dx. So you'll see as I explain the examples in the homework, how I figure out what that point is and what my area is. And so the way that the book describes it is find that switchover point, where the top function and the bottom function switch places, f of x and g of x switch places. And if you look for a point between -2 and x1, find that value, and whichever one gives you the greatest would be the function on top. So that's the explanation they're going to show you in the textbook. But I will give you the graph, and I'll give you the shaded area I want, and you'll just set up your integrals and do the integration to find the area.